Now that we have learned about Boyle's, Charles, and Gay-Lussac laws, we now can combine all three into one statement. Let's do a quick review. Boyle's law is talking about the relationship between pressure and volume. We learned that if you increase the pressure on a gas, the volume decreases. And that means it was an inversely or indirectly proportional statement. We wrote the half equation of P equals K divided by V. If we solve this equation for K, we get P times V. Charles' law talked about the relationship between volume and temperature. If your temperature increases, the volume of the gas increases. And we say it's directly proportional, and we wrote this equation. We then solve the equation for K, and we get the equation V divided by T. And then we move to Gay-Lussac, which was about pressure and temperature. As the temperature inside a closed container increases, the pressure inside also builds, so it's directly proportional. And we solve this equation for K and get P divided by T. Now you will notice that all three equations are set equal to K. And because they're all set equal to K, let's combine them. So we say equal to K. We see that pressure is in the numerator and in the numerator, so we put pressure in the numerator. Volume is in the numerator and in the numerator, and we put it in the numerator. Temperature is in the denominator and the denominator, so it goes in the denominator. So now, nothing is being held constant. Pressure, volume, and temperature can all change, and they can all change in a way that is equal to whatever this constant value K is. So we can have an initial pressure, an initial volume, and an initial temperature equal to a constant. If I change one of these three variables, everything's going to change. So I have this half equation and this half equation, and I can combine them to make a statement that says P1V1 divided by T1 equals P2V2 divided by T2. To remove the fractions, we can cross multiply. And now we will have P1V1 times T2 equals P2V2 times T1. If you were to cover up the temperatures, you would have Boyle's law. If you were to cover up the pressures, you would have V1T2 equals V2T1, which is Charles' law. And the same with the volumes. If you covered up the volumes, you'd be back to Gay-Lussac's law. So in theory, you can use the combined gas law equation for every single problem out there that we have done so far. It is important to remember, since we're dealing with temperature, your temperature has to be in kelvins. So make sure if you're given a degree Celsius to add 273. So let's look at an example problem. It says a sample of carbon dioxide gas occupies 638 milliliters at 0.893 atms and 12 degrees Celsius. What will the pressure be at a volume of 881 milliliters and 18 degrees Celsius? So what we'll want to do is make our list. So the first piece of information is I'm in milliliters. That's my volume. So my V1 is 638 milliliters. I have 0.893 atms, which is my pressure. Atmospheres measures pressure, that's my P1. And I have a temperature at 12 degrees, my T1. And I will want to make sure that I add 273 and use the Kelvin value. What will the pressure be? So I'm looking for P2. When the volume becomes 881 milliliters, that's my V2. And my temperature changes to 18 degrees. Again, add 273. Okay. Since I have both pressure, all pressure, volume, and temperatures being used, I have to use the combined gas law. So make sure you write the equation down properly. We will be solving for P2. So find P2 and circle it. Once we circle P2, that means we have to get rid of V2 and T1. you're multiplying P2 by both V2 and T1. So the opposite of multiply is divide. So you are going to divide this side by V2 T1 so they can cancel. And you'll have to do the same and divide by V2 T1 here. Now we can substitute in our values for each of those variables. So P1 will be replaced with a P1 will be replaced with a 0.893 ATMs. My V1 will be replaced with 638 milliliters. And this is T2, so I need to use 291 K. I will then divide it by V2, which was 881 milliliters, and I will divide by T1, which was my 285 K. You will see that milliliters is on top and on the bottom, so they will cancel. Kelvins is on top and on bottom, they will cancel. That will leave me with ATMs, which is the correct unit for pressure. How to plug this into your calculator? It's 0.893 times 638 times 291. Then you're going to divide by 881, and you will divide by 285. Make sure you hit divide because it's underneath the division line. And when you plug that into your calculator, you will get 0.660 ATMs. I went to 3 significant digits because my problem had 3 significant digits.